Hey guys, so today what we're going to do is we're going to go backwards a little bit. We're going to go into chapter 8, which is a chapter that is on radicals. And radicals, all they are roots of a number. Okay? And the reason we're going backwards is I think that some of you guys need help in order to figure out this part of the quadratic formula. So I believe that if we go back to chapter 8, we're going to look at radicals, and radicals are basically roots of numbers. The most common radical that you guys are familiar with are square roots, right? So square root of 36 equals 6 because 6 times 6 equals 36, right? So a radical is the opposite of an exponent, right? Just like adding is the opposite of subtraction. Multiplication is the opposite of division. And then exponents are the opposite of radicals or roots. Okay? So square roots or exponents, the opposite are radicals. Okay? So you guys are familiar with it with squares. So let's just say 5 squared equals 25. If I take the square root of 25, it equals 5. Okay? Now, it doesn't just stop at square roots. Okay? Radicals cover all kinds of roots. They cover cubed roots, roots to the 4th, roots to the 5th, and so on and so forth. So, if we have 3, 8, this is your, what we call is an index. This tells us the root, okay? Tells us the root. So there has to be a number within the radical with an index of 3 that can be multiplied by itself 3 times, because index tells us 3 times. Well, is there a number that can be multiplied by itself to equal 8? And this 8 is called the radicand. So is there a number that can be multiplied by itself 3 times to equal 8, which is the radicand? That is the number inside the radical. Well, yes. Okay? 8 equals 2 times 2 times 2. 2 times 2 times 2 is also equal to 2 cubed. Right? So, this guy right here can be rewritten as 2 cubed. Right? So the answer to that is going to be 2. Does that make sense? Right? It's actually 2 to the 3 divided by 3, which is 2 to the 1, which is 2. Okay? That's what that means. Alright? What you guys are used to is me giving you one of these guys, and then you go, hey, that's 4. But remember, it's plus or minus 4. Because 4 times 4 equals 16, and negative 4 times negative 4 also equals 16. So we have to make sure we understand that a square root, okay, a square root is plus or minus. Any root, let's do an index, like that. Okay? We have an index of 4, and we have a radicand of 16. So what number can be multiplied by itself 4 times, okay, to equal 16? Well, that's a pretty simple one. So 4 into 2 times 2 times 2 times 2, right? So that would be 4 of 2 to the 4th power, right? So the answer This is even. And anytime it's even, it's going to be plus or minus the answer. Okay? Hopefully you guys understand that. Okay? Now, in your book, there's a lot of examples here. So let's start going through some examples, and when we do examples, some of this will make more sense to you. All right? So, we are going to look at Chapter 8, Section 1. All right? And what we're going to look at is on page 276. This is something you guys need to know, is the quotient rule. What is the quotient rule for a radical? Well, the quotient rule says that if I have square root of, what do we got here? We got A over B to some index. That index can be 2, 3, 4, 5. Okay? That equals the radical of A to that index over the radical of B. We can separate the radical into the numerator and the denominator. Okay? So let's do an example of that. What does that look like? All right? What is the square root of 49 over 144? Well, we can break that up into the square root of 49 over the square root of 144. Well, we know the square root of 49, right? That's 7 times 7. So that equals 7. And we know the square root of 144 is 12 times 12. So that is 12. All right? So your answer would be 7 over 12. And you can see how we use the quotient rule for this, where we have the square root. Right? Our index was 2, because this is square root. Right? We could write that there and write that there. And what I could do is I could split the numerator and the denominator up into their own radicals and then solve those to come up with our fraction. Okay? That's a way to use the quotient rule. All right? Another way to use it, here's another way to use it. What if you had, we're looking at example 8.1c, what if you had the square root of 0.09? Well, that's a decimal, so we can actually rewrite that as the square root of 9 over 100. 9 over 100 equals 0.09. And then we can use our quotient rule by splitting up this radical into the numerator and the denominator. And then we can solve that. Well, what's the square root of 9? Well, 3 times 3 equals 9, so 3 over, what's the square root of 100? Well, to get 100, it's 10 times 10, so it's 10. And that is your answer. So the square root of 0.09 is 3 tenths. Okay? So, let's look at some that actually have variables in them. So let's look at example 8.1d. 8.1d has x to the 8th, the square root of x to the 8th over 4. Well, what does that equal? We can use our quotient rule to break this up. So we've got the square root of x to the 8th over the square root of 4. Square root of x to the 8th, what multiplied what equals x to the 8th? The same thing. Well, when we multiply exponents, right, we add the exponents together. So this would equal that, right? that would be over the square root of 4. So the answer would be x to the 4th over 2. That is your answer. Okay. One other thing that you might want to understand, you guys should have already learned this, but I will remind you that if you have the square root of x, okay, any number, what you can do is that would be the same thing as x to the exponent of 1/2. This equals itself. Okay? So if I had the square root of x to the 8th, now remember, square root, there's a 2 out here, right? And that's a 1, so you can see where the 1 comes from, and the 2 comes from the index. So let's look at this. What is the square root of x to the 8th? Well, just like here, we know that that's going to be x, okay, the radicand's exponent, which would be 8, over the index. So that'd be x to the 8 over 2. Well, what's x to the 8 over 2? What's 8 over 2? Equals 4. X to the 4th. Okay? Hopefully that makes sense. Okay? If I had the cubed root of x to the 9th, okay, I can write that as x to the radicand's exponent, 9, over the index, 3, which equals x to the 3rd. 9 over 3 is 3. So you take the exponent of the radicand, and you put that in the numerator, and then you take the index and you put that in the denominator as an exponent to your variable. Okay? Now, does that work? Right? Does x cubed multiplied by itself 3 times equal x to the 9th? Well, sure it does. We got x cubed times x cubed times x cubed. Right? Remember the exponent rule? This would be the same thing as x to the 3 plus 3 plus 3, which equals x to the 9th. So it works out. Okay? So I think this is a little tip right here and a rule that you need to know with radicals. Okay? All right. So let's look at some problems for you guys to do. I'm going to erase this. All right. What I want you guys to do is I want you to simplify the following radicals. And that is going to be found on page, so this is your homework. It's going to be page 278, numbers 15 through 30. Okay? So it says find the principal root. If the root cannot be found, write not real or irrational. Okay? So I'm going to do an example for you. I'm going to do number 23. So number 23 says 289 square root of 289 r to the 8th y to the 4th. What does that equal? Well, let's see. Do we have a number that can multiply? Here's a good one. 289. What's the square root of 289? Well, 3 would go into that, right? So 3, that would be 9. No, that's not going to go into that. Huh. I think this one's irrational. I picked an irrational one. Irrational. All right, so let's do another one. Let's do, what is the square root of 289? 289. Is 17 times 17? Let's try that. 17 times 17. It'll be 9, 4, 1, X. Aha! Yes, my bad. Let's go back to number 23. Let's solve it. All right, number 23. Okay? So, what we can do here, all right, is we can also do the product rule, which we did not go over. I don't know why they didn't go over that, but that's okay. But what we can do is when we have different variables, we have a coefficient, we have a variable, and we have a variable. Okay? Each one of these can be broken down by that radical. Okay? So essentially, I can write this as the square root of 289 times the square root of r to the 8th times square root of y to the 4th. So we can break this down. So square root of 287 is 17 times the square root of r to the 8th, which is r to the 4th, okay, times the square root of y to the 4th, which is y squared. And if I multiply them all together, I get 17 r to the 4th y squared. So that is my answer. Okay? So that's what I'm looking for you guys to find in each one of these from 15 through 30. If you have any questions, shoot me a message. I'll go ahead and do a special video for you to show you how to do it. Okay? All right, good luck with this, guys. We'll see you tomorrow.